Hi to everyone. In this video, I am just going to discuss about us how to derive the spanning tree of minimum cost from a graph. Okay, I am just going to derive the spanning tree of minimum cost using Kruskals algorithm. Okay. So for such a thing, at first I should look into my graph. How many vertices are here? 6 vertices are here. Ranges from 1 to 6, and so many edges are here. Every edges are weighted. Okay. So at first I should arrange all these edge list in an ascending order. For example, which one is having the minimum weightage? 5. Right, so 5 is the minimum weight here. Okay, I am talking about the weight along the edge. So the first pair here is 2 comma 3, and next one is next to 5 I am having 6. It's 2 comma 4. Okay, next to 6, which one is the value? Least one means it's 10 only. Okay, so here I am writing 4 comma 3. 4 comma 3 and 3 comma 4 both are equal. Next to 10 I am having 11. So here I am writing, I may write it as 2 comma 6 or else 6 comma 2, no problem at all. For my convenience, I am writing it in the ascending order. So here 2 comma 6, and next to 11 I am just having 14. So I am just going to write 4 comma 6 here. Okay. Next to 14 I am having 16 here. So I have to write here 1 comma 2. Next to 16, what's the value here? Next to 16, I am having 18. So I am writing 4 comma 5. Next to 18, I am having 19. So I am writing 1 comma 5. Next to 19, I am having 21. Right? So I am writing 1 comma 6. Okay, I'm writing 1 comma 6. Next to 21, what's the element, what's the age? 33. So I'm writing 5 comma 6. So I have covered all the edges here. Okay, so after writing all these things, what I'm just going to do it here is I'm just going to tabulate the values here. How I'm just going to tabulate it here is, first I'm just going to write the age, and then I'm going to write the corresponding cost for that age, and then action to be carried on. Am I going to accept that edge or else not? Okay, then I have to write the vertices here, 2 3 and then 4 5 6. So 6 vertices are here. I have written all those things. Okay, so initially what I'm just going to do it here is, initially no age, no cost, and action is also null. You can write all these ages as it is. Okay. Then what I'm just going to do it here is, first I'm going to select the age. First one, what's the age? First one here 2 comma 3. So I'm writing 2 comma 3. What's the corresponding weight? It's 5. Okay. Okay. Then I have to write all these ages here as it is. I have to write it here, and I have to draw a line between the vertex 2 and 3, and I can accept this one. Okay, why I am going to accept this one means, because There is no other edge which is covering the vertex 2 and 3 in these vertices. Okay. So this is the first edge which is covering 2 and 3. That's why I can accept this one. And next to this one, you can take the next one, edge 2 comma 4. What's the weight for 2 comma 4? It's 6. Write the cost here 6. You just see here 2 is already covered here, but the vertex 4 is not at all covered, right? So in such a cases, we can accept this edge because 2 is already covered, but the vertex 4 is not at all covered, no. That's why we can accept this one. So you can accept this one. If you are accepting this one, you can draw the line, draw the edge from the vertex 2 to 4. So you can write 4 here and you can write it here. So the rest of the vertex here are 5 and 6 and 1. Okay, next you can take for the edge 4 comma 3. Okay, for 4 comma 3 the weight is 10. You just see here and the action to be carried on here is 4 is already covered here and 3 is also already covered here. So it's not necessary to accept this one. We can reject it, okay, because 4 and 3 vertex has been covered already. Okay, so the next one is 2 comma 6. Okay, while checking these things, 2 is covered already, but 6 is not all covered. So we can accept this one. But before that, we have to check the weight for this one. For 2 and 6, it's 11. It's 11 and we can accept this one. Okay. So while accepting this one, you can draw the edge 6. Okay, sorry, edge and the vertex as 6. You have to maintain all these things. So here 5 is available. Okay, next what I am just going to do it here is I am just going to take the another edges 4 comma 6. What's the value for the weight for 4 comma 6? 4 is here, 4 comma 6, it's 14. So 14 here. But you just see here 4 is already covered and 6 is also already covered. So I can reject it. Okay, next one is 1 comma 2. When I am taking 1 comma 2, what's the weight? It's 16. So you just write 16 here. The 2 is already covered in this tree, but 1 is not at all covered. So we can accept it. If any of the vertex is not at all covered, then you can accept that edge. Okay. So we will get the tree like 6 and you can write like this one. Okay. So now you just consider here the vertex 5 alone is available. Next I am just going to take 4 and 5. See here I am writing 4 and 5. What's the weight for the age 4 to 5? It's 18. So I am writing 18 here. 4 is already covered but 5 is not at all covered, right? So I can accept this one. I can accept this one. And what about the tree for this one is, since the space is not all available, I am just writing it here. So 2 here, then 1, and here you are having 3, you are having 4 and 6, and then you are having 5 here. Okay, so 5 here. So next one thing, after doing these things, I can take the next one, age 1, 5, but 1 is already covered and 5 is also already covered. And in this step, you can notice one thing, no other vertex is left out because all the vertices are covered here. So what's the conclusion here is, I'm just drawing that one here and 2, connect these things, right? So you will, here you are having 6 and then 5, 4, connect it, yes, then you are going to have 3 here. Okay, so you just see here, this is the spanning tree of minimum cost. You can just check it out. So from 1 to 2 you are having 16, and here you are having 11, and 5, 6, 18. So you can take up this original graph and you can consider this spanning tree with minimum cost. Check it here. Spanning tree definition that you know very well. We are just going to cover all vertices with minimum number of edges. Here what we are doing, we are just going to cover minimum number of edges with minimum weightage, that's all. So see here, what are all the edges connected with the vertex 1. So which one is the minimum? 16. So 16 is here, and this edge is connecting the two vertices 1 and 2. Okay, and here you are having the edge which is connecting 2 and 3. While taking the vertex 3, what are all the edges? 5 and 10. So which one is the minimum? 5. So we have covered 5. And for 10, which one is the minimum value? 6 is the minimum one. We have written it rightly, 6. And for 5, what are all the weightage? 19, 33 and 18. Which one is the minimum? 18. So 18 is also covered here. While considering the vertex 6, 33, 21, 11 and 14. So 11 is the minimum one. It is also covered here. So what I am just concluding here is, it's a spanning tree of minimum cost. We have derived these things by using Kruskals algorithm. This is a methodology of tracing the minimum cost spanning tree. I hope that every one of you got a clear idea about this one. In case if you are having any doubts, kindly post your queries. Thank you.